Hello learners, I Kriti Verma, faculty of Jharkhand Rai University. In PhD coursework, today I am going to take a topic univariate and bivariate data. In this lecture, I will explain about what is univariate and bivariate data, in which field it is used, and what are the examples of univariate and bivariate data. So, univariate and bivariate data. As the name univariate, uni means one, variate means variable. So, univariate means one variable. So, one variable means one type of data. Here, one example is given in which travel time is 15, 29. In minutes, it is 29, 8, 42, 39, and 21, 18, 42, 26. So, this is our data, but this whole data represent a same thing, that is travel time. Okay, so this is a univariate data. Similarly, second example is puppy weight. In puppy weight, it is given 2.5, 3.5, 3.3, 3.1, 2.6. So this is the data, but this whole data represent a single thing, that is weight of puppy. So this is also a univariate. With univariate data, we can find a central value using mean, median, mode. This is also known as measure of central tendency. Okay, this is measure of central tendency. We can find how spread out it is using like a range, quartiles, standard deviation. So this is also known as, these all known as measure of dispersion. With the help of these, we find out that how much scattered any data is, means what is the fluctuation rate of any mean, median, or mode. So with the help of univariate data, we can find out this. Okay, with univariate data, we can draw a bar graph, pie chart, and histogram. I will explain in deep in next lectures that what is measure of dispersion, what is measure of central tendency. So first, only you have to just keep on your mind that univariate means one variable in which only one kind of variable is explained. Now next is bivariate. What is the meaning of bivariate? Bivariate, as the name is, bivariate. Bi means two and variate means variable. So in other words, there are two types of data. Means in bivariate there is two types of data. For example, here ice cream sale versus temperature. Two kind of data is there, temperature and cell. You know that as temperature is increasing, the demand for ice cream is also increasing, and as temperature is decreasing, the demand of ice cream is also decreasing. So in this example, there is a sale versus temperature. An ice cream shop keeps track how much ice cream they sell versus temperature on that day. So this is a human tendency, this is a common tendency. So we know that as the temperature will increase, sale of ice cream will also increase. Okay, we know this earlier only, but there are also some variables, there are some variables in which we have to compare. We don't know what will be the actual result of that two, what is the actual relationship between two variable. So bivariate data gives two variable data in which of two variables. Like here you can see that if temperature is 14.2, then sale is 215, 16.4 the sale is 325, 11.9 then 185. So with the help of this data, we will draw a scatter diagram. Here you can see the scatter diagram. Here you can see the scatter diagram. Like in x-axis it is temperature, and in y-axis it is sales. Okay, so x-axis temperature and y-axis sales. So here I have shown the temperature from 10 degrees Celsius to 26 degrees Celsius, and the profit and the sale is 0 to 700. So according to this, we have just plotted a graph. Like when temperature is 11.9, then the sale is 185. When the temperature is 5.2, then the sale is something about 220. Means according to these points, you can predict that what will be the value. Similarly, like this, we have just plotted a points. Now with the help of this point, you can draw a line. Like the tendency of this point is like this. Okay, means what this line is showing, what is the actual meaning of this line, that as the temperature is rising, Okay, earlier it was 10 degrees Celsius. Now it is 26, means it is rises up to 26 degrees Celsius. As the temperature is rising, the sail is also rising. Okay, you can see that it's from earlier it was from 100, it is in 100, and now it is in more than 600. So as the temperature is rising, the sail is also rising. So this kind of relationship, this kind of comparison can only be we get with the help of bivariate data. If suppose you have only temperature, you don't have any other quantity to compare, then how we will make a relationship, how we will make a comparison. So bivariate data is generally used when we are interested in comparing the two sets of data and finding any relationship. Okay, so whenever we are taking bivariate data, then generally we draw tables, we draw scatter plots, we draw correlations, line of best fit, and plain old common sense. Okay, so this is the way through which we make a relationship, we find a relationship, we compare the two sets. Now next is difference between univariate and bivariate data. Now, a common difference which is very common in univariate and bivariate data is that in univariate data there is only one variable, single variable, and the bivariate data involves a double variable. This is the common difference. Okay, so in the first difference I have written involving a single variable, involving a double variable. So this is the common difference. Second one is does not deals with causes and relationship. If we are interested in causes and relationship, that what will be the circumstances of anything of any relation, then we don't means there is no use of univariate. If you have to deal with a cause and relationship, then you have to move through bivariate data. The major purpose of a univariate analysis is to describe central tendency, and in central tendency there is mean, mode, median. Then dispersion. Dispersion means range, variance, maximum, minimum, quartiles, standard deviation. Okay, so maximum, minimum, quartile, standard deviation. These all are um, scatteredness. Means if suppose you are finding out a mean. Okay, you have find out a mean, then how much mean will fluctuate, means what is the level of deviation. Okay, how much it will deviate from its actual value, that is only the standard deviation and variance. Quartiles, as suppose this is a median, means suppose this is a data. Okay, here I have written so many datas are there. Okay, and if suppose you will just make it half, two half, then the mid value, you know that it is known as median. Okay, now what is quartile? Quartile means if suppose this is a data and you have to just divide it into four parts, then what you will do, you will just you will draw three lines so that it will divide into four parts. Okay, so this is known as q1 first quartile, this is known as q2 second quartile, and this is known as q3 third quartile. Okay, means with the help of quartile we just divide any data which is in ascending or descending order into four parts. And with the help of median, what is median? Median means with the help of median we just divide any data into two equal halves. The middlemost value is known as the median. And quartile, if you will divide into four part, then the values are known as quartile. So in this one, in this we are finding q1, q2 and q3, and q2 is only known as median. Okay, so these are the values. Frequency distribution, I have also explained this with the help of here, like this is known as, this one is known as bar graph, this one is known as pie chart, this one is histogram, and this is line graph. So these all kinds of graph needs univariate data. Okay, no, like here it is 10 companies who are sprinting ahead in terms of revenue. So revenue is the one, is only variable. So this company have revenue this much, this company has revenue this much. So the variable is what? Revenue, that how much revenue each company have. So one variable, that is revenue, can be represented with the help of bar graph. So students, so generally what happen, learners are a little bit confused in bar graph and histogram. So while making bar graph we have to give spaces between these two. But while making histogram there is no spaces, you have to just merge all these and you have to draw. Okay, so this is pie chart and this is line graph. So with the help of pie chart also we just show one variable, single variable, and line graph is also used for univariate data only. Similarly, like now I have discussed about median and mode. So suppose this is a univariate data, okay, and this is the graph. Okay, this is the graph. So what is the meaning of mode? Okay, mode, what is the meaning of mode? Mode means the highest value is known as mode. Okay, see here, if this is a graph, blue one is a graph. Okay, I'm just using another pen. This one is a graph. Okay, so at which point it is having a highest value? See this red one, red line, this red line is showing at which point it is a highest value. So at this point it is a highest value, so this is a mode. Mode means at the point at which it is a highest value. Okay, so or more values, so this is the mode. Median means what? Median means green one is median, so look into the green part, this one is green. So median means the mid value. If suppose the if suppose data is from here to here, okay, so the mid one is the green one, which divides this whole data into two equal halves, that is known as median. Okay, then blue one is mean. Mean means average of this whole univariate data is known as mean. Okay, and here this sigma denotes standard deviation. So standard deviation is 0, means it's just example. So this is the mode. Mode means what? The which occurs most, that is known as mode. So if in a graph it is showing like this, okay, like this, it is here it is highest highest fluctuation is there, so it means this one, this part is occur most, so this is the mode. Median means you know that the middlemost, and mean means the average value. Similarly, measure of dispersion. In measure of dispersion there are, in measure of dispersion there are two kinds of measures are there. One is algebraic measure, another one is graphical measure. Okay, in algebraic measure there is also divided into absolute measure and relative measure. Now in absolute measure we are finding out range, quartile deviation, standard deviation and mean deviation. And if you will go to the relative measure, then there is coefficient of range, coefficient of variation, coefficient of quartile deviation, coefficient of mean deviation. So this is all about the dispersion, and we will study in deep in next lecture about measure of central tendency, how to find out mean, median, mode, how to find out range, quartile deviation, standard deviation, mean deviation, what is these coefficients. Coefficients are generally denoting the percentage value of anything. So now we will go back to the differences. So in this way we just, with the help of univariate data, which central tendency can be explained very properly, dispersion, frequency distribution, bar graph. Now you know that what is bar graph, histogram, pie chart, line graph, box and whisker plots, like these things you can express, you can analyze very easily with the help of univariate data. Now come into the bivariate data. So we know that bivariate data is a double variable. It deals with causes and relationship. If a candidate is interested in a cause and relationship between two variables, then he should go for the bivariate data. The major purpose of bivariate analysis is to explain analysis of two variables simultaneously. Correlation. Correlation means before going in depth of correlation, you should know that what is correlation. Correlation is also a relationship between, the extent of relationship between two variables. Okay, so in next lectures we will study in deep about correlation. Just I will give a rough idea about correlation, that if suppose two variable are there, if suppose two variable are there, x and y. Okay, if x is also increasing and y is also increasing, then we will tell that it is positive correlation. Okay, and if x is decreasing and y is also decreasing, then also it is positive correlation. Okay, like like if you will increase the quantity, then price will also increase. Okay, if you will decrease the quantity, then price is also decrease. So this kind of kind of relation is known as positive correlation. Okay, now I'm just talking about negative correlation. The negative correlation, if suppose something is x is increasing and y is decreasing, okay, or x is decreasing and y is increasing, then this kind of correlation is known as negative correlation. Okay, this kind of correlation is known as negative correlation. Like suppose if you will increase the number of workers, then time taken to complete a work will decrease. If you will decrease the number of worker, then time taken to complete a work will increase. So this kind of correlation is known as negative correlation. One more example I can give in this, like if price will increase, then demand will decrease. If demand will increase, it means price is decreased. So this kind of thing is known as negative correlation. So with the help of bivariate data, we can find out the correlation. Comparison relationship causes and explanation best expresses with the help of bivariate data. Tables where one variable is contingent on the value of the other variable, means sometimes in regression it is happening that with the help of x we are going to find out y. So we will also discuss regression in the upcoming lectures very properly. Independent and dependent variables, these kind of also data, like some of the data are also there, which is one data is independent and another is dependent on that independent one. So this kind of things, this kind of analysis can be done with the help of bivariate data. So I'm just explaining correlation more properly here with this example. Like correlation, differences between correlation and regression. What is correlation? This is a part of bivariate data. So with the help of this diagram, I am just explaining correlation. Okay, uh, when we use correlation, when we you want to know there an association between two variable. Okay, because sometimes it is happening that your correlation value is 0, then this 0 shows that there is no correlation. Okay, like strength and direction of relationship, if minus 1 is perfect negative. Perfect negative means there is, you don't have to think that whether it is increasing then another one is decreasing or not. Means minus 1 is, it's perfect negative, means one will increase then other will definitely decrease. Okay, this kind of correlation is known as perfect negative. Perfect positive means if another one is increasing, then another one will also definitely 100% it will increase. That is known as positive correlation. And zero means no correlation. There is no correlation between production of wheat and the marks of a student. Is there any correlation between these two, that production of wheat and marks of the students? No. So in this kind of example we will get 0. Validity, valids measurement, a good sample, confounded comparison, distribution, linear relationship between two. Means with the help of this kind of graph, this linear, if it is moving from down to up, this shows that positive correlation. If it is coming from up to down, this shows that negative correlation. So with the linear graph we can show easily correlation. Okay, now another one is regression. So regression is what, when you want to predict how one variable will change with another variable. Means when we are interested on what is the effect if I will change x, then what will be the effect on y. So this kind of thing we can do with the help of regression. Okay, so regression is means generally in regression what is happening, two variables are there, x and y, and x we can express in terms of y, like 2y plus 6. Okay, and if you will put in place of y1, then the x value will change. If you will put in place of y2, then value of x will change. If you will put in place of y3, then the value of x will change. So in this way regression is totally finding out y if x is given, or finding out x if y is given. So regression is this kind of thing. So all the above plus quantitative data, outliner condition, independence of error, homoscedastic normality of error distribution, these kind of things all can be assumption. These kind of requirements are there while doing a regression kind of things. Now next is bivariate. Yes, bivariate data. So here I am just explaining that how bivariate data is is able to give, say here two kind of variable are there, height and weight. Okay, now first we have drawn a scattering. This is a scattering diagram in which just so many dots are there, so many data I have taken and so many dots are there. So you have to see the tendency of this data. It is just moving like this, it is just like this. Okay, now so this is the tendency. It is just going up from down to up, it is going. Okay, so this is the tendency. So if it is this kind of tendency is there, means it is going up, down to up. It means as the height will increase, the weight is also increasing. As the height will increase, the weight will increase. So this kind of data is known as bivariate data. Okay, in which two variables are there, and we are just doing our assumptions, we are finding out the comparison relationship. So we also know that as a height is increasing, the weight is also increasing. But with the help of a graph, with the help of data, it is providing the it is proving the truth. It is proving the just perfect calculation, perfect relationship between these two things. Now types of analysis, here we are going to do two types of analysis. One is descriptive analysis and another one is inferential analysis. So so what is descriptive analysis and what is the inferential analysis? Just just see here. In descriptive analysis, descriptive is a statistic is the term given to the analysis of data that helps describe, show or summarize data in a meaningful way, such that for example patterns might emerge from the data. Okay, descriptive means descriptive statistics is the term given to the analysis of data to help describe, show, summarize data. Means data is given, and with the help of that data only you have to summarize the thing. You don't have to just go beyond the data. Descriptive statistics do not allow us to make conclusion beyond the data. Means you cannot go beyond the data. Whatever the data is given, according to that only you have to just give the conclusion. Okay, we have analyzed all reach conclusions regarding any hypothesis we might have made. They are simply a way to describe our data. Means generally in descriptive data you don't have to move further. You don't have to go beyond data. Means if data is telling that the rate of change is 10%, 2% or 3%, then you just have to stick to the data. You don't have to make a probability or make any other conclusion with the help of data. So this is known as descriptive analysis. Inferential analysis. Inferential analysis, what is inferential analysis? Inferential statistics take data from a sample and make inferences about the larger population from which the sample was drawn. Okay, means inferential statistics takes data from sample. Means first we have just taken a sample. From that sample we make inferences about the large population and from which sample was drawn. Okay, with the help of sample we just make inferences about larger population. Like if in this small population this kind of change is there, so for larger population also same kind of changes is possible. So this kind of analysis we are doing with the help of inferential analysis, because the goal of inferential statistic is to draw conclusion from a sample and generalize them to a population. We need to have confidence that our sample accurately reflects the population. This requirement affect our process. Okay, so means what is happening here, that if suppose we have to make a conclusion, then we have to first take a sample. Okay, with the help of that small sample we will first take whatever the things are there, that what is the ratio of suppose I have taken a small sample from a large population and we have just calculated a ratio of male and female education rate, what are the education rate, how their health condition is there, how many hospitals are there. Means whatever the things, all the primary things which is important we have just taken out. Okay, and with the help of that small sample we are finding out, we are just coming up to the conclusion that the larger population will have also this kind of same ratio of male and female. They have also same kind of means literacy rate. Okay, so inferential analysis if you are doing, then there is a chance of some error, because we with the help of a small sample we are going just moving to the larger one, so there is a chance of error. But if you are doing descriptive analysis, because descriptive analysis, for descriptive analysis we are stick to our data. If data is showing this ratio between women and female and male is 16 is to 9 suppose, then we have to just stick to this only, this data only. We cannot make a conclusion that yeah, for more larger population it will be another one. So this is descriptive. And inferential, that okay, in this state if it is 2 is to 3 ratio, then in another state will be this. So in that kind, in inferential analysis we are doing, we are just what we are doing, we are making a sample, and inferences about the larger population has been done. So at a broad level you can see we must do the following. We have to define the population we are studying, draw a representative sample from the population, and use analysis that incorporate the sampling error. But generally what is happening, that inferential analysis is more convenient than descriptive analysis. Therefore generally researchers are using in an inferential analysis. So this is very important, this is very simple, and with the help of this at least we can come up to some conclusion. But there is a chances of error. So this is all about today's lecture. In this lecture we have studied that what is univariate, what is bivariate, how it is used in measure of central tendency, dispersion, and correlation regression, what is the types of analysis like descriptive analysis and inferential analysis. Hope you all have understand this. But still, you if you have any doubt in any kind of thing, you can ask in discussion forum, which will be generated at the end of the week. So whatever the things has been done, just go through it. Thank you.